Do we live in a simulation? Today's guest claims there's powerful evidence that we live in a simulation, but why?
I became intrigued by this idea that there was a whole world inside the computer. And originally, with the text adventures, we were visualizing it in our heads, but then with graphic adventures, we were suddenly able to see this world. But I always wondered what was beyond the boundaries of what could be seen.
But is there really evidence that we live in a simulation?
Our reality is not actually physical like this table. It's actually a virtual reality.
Today's guest, Dr. Rizwan Virk, explains exactly why he thinks it's more likely than not that our whole existence is a mere manifestation of a master simulation taking place in the universe. Let's go. Thank you so much for coming on.
Absolutely. Great to be here.
We'll go through the book and take everybody on a journey. First of all, I want to present you with the Keating Medal for Impossible Imagination. There it goes, with a picture of Arthur C. Clarke, and he plays a role in this book. Minor role, but a role nonetheless. And of course, you've been to his house, unlike me. What was that experience like when you went there? Were there monoliths like this little beauty over there?
There were a lot of pictures of monoliths, and there were pictures of him with David Prowse from who played Darth Vader. Pictures of Arthur C. Clarke with the moon landing astronauts. It was really interesting because they preserved his office, and generally speaking, it's not supposed to be open to the public, but any foreigner who goes there and slips a few rupees to the security guard will take you up. And, he's got all of his books there, and, plays a minor role in my book, because it was during that visit when I was looking at behind his desk, I saw many of my favorite books from when I was growing up, like 2001, A Space Odyssey, 2010, Odyssey 2. And I saw all these different translations. And I had one of those moments that we sometimes have when we get inspired. And I had wanted to be a writer for a while. And I just had this intuition that it was time for me to get busy on the writing side, because I'd been spending all my time in Silicon Valley, first as an entrepreneur, then later as an investor. And it was during that time that I wrote the article about why I think we live inside a video game that led to this book eventually.
I noticed in this book, reading it, that there was this connection between something that happened in my childhood, which might have had an impact on my career, and it was the video game Adventure, which featured a virtual world. But more than that, it featured the very first real Easter egg, as far as I understand it. So Easter egg being a hidden message encoded, encrypted, which if you took this magic zero-dimensional pixel and you transported it left, right, up, down, side, back, diagonal, and up, you'd come to a secret chamber. And then if you move the joystick to just the right position, you would drop the pixel and you would enter this room where there'd be some flashing lights. I mean, a room. It was a square with a dot, and the zero-dimensional pixel unlocked this message, which came from the designer Warren Robinett, and it said created by Warren Robinett. That's basically it. For 1981 or whatever I was, it was amazing that I had unleashed and unlocked the evidence, proof positive that this was living in a simulation. Tell me why you think that we are of greater odds than not that we live in a simulation.
Well, if you think of the simulation hypothesis, and I think we share a history there in terms of having played video games on the Atari computer, which is where Adventure was. But before that, there were text adventure games, and I became intrigued by this idea that there was a whole world inside the computer. And originally, with the text adventures, we were visualizing it in our heads, but then with graphic adventures, we were suddenly able to see this world. But I always wondered what was beyond the boundaries of what could be seen. So, for example, there was a racing game called Pole Position. And I used to wonder, well, what's beyond the racetrack? You'd see a mountain that looks like Mount Fuji, or you'd see some bleachers with some fake people. I mean, they weren't really people. They were like a few pixels, right? But I'd always wonder what was beyond the mountain, what happens to those people when I'm not logged in, etc. And so that kind of inspired me later when I became a video game designer to really start thinking about this. So the simulation hypothesis, if you were to define it, I like to say it's the idea that our reality is not actually physical like this table. It's actually a virtual reality, like that depicted in the film The Matrix. But I also like to think of it as a series of propositions. And you can agree with some of those propositions, but I think they kind of follow logically one to the other. So the first is that the world is not actually physical, but that it consists of information or bits of information. The second is that that information is getting computed all the time. And the third is somehow that information is rendered for us. And it appears as if, this microphone is a physical object. And then, the last proposition is that this is all some kind of purposeful hoax. Now, different people have different opinions on each of those, but I like to lay it out that way because then you can discuss the different parts of what makes up the simulation hypothesis. I see it as an axis where on one end of the axis, it's really just a metaphor, where the video game is a metaphor for something very complex called reality. At the other end of the axis, we take it very literally and say the world is literally a computer simulation running on some type of advanced computer, probably way more advanced than what we've been able to think of thus far. And so the book tries to explore it from all of these different angles. That's why I touch on religion, philosophy, video games, quantum physics, etc. And some people in the scientific world give me a hard time for spending time on the religious side, for example. But I like to show that they were using metaphors in the past, and this is a new type of metaphor that makes more sense, a techno-scientific metaphor.
Yeah, in my conversations with Nick Bostrom, a few times he's been on the podcast, I mean, he's candidly admitted that, there's nothing really that could be used to differentiate either the existence of the multiverse from the falsification of that proposition. And we'll talk about how scientifically we could prove or at least emphasize the evidence for the simulation hypothesis, but also that it does connect to prospects and propositions regarding teleology and what would be the purpose of such a thing, which naturally then invokes questions like the simulator, he or she or it or they. What are some of the tangible physical advances that have led you to believe there's more preponderance of evidence for the simulation hypothesis than not? What is it coming from? AI advances, game advances? Is it coming from quantum computing that we explored in my laboratory earlier today? What is most kind of convincing to you, just at a basic level?
Well, I think at a basic level, it's all of those things happening in parallel. And I often tell the story that after I sold my last video game company, I was visiting a startup in Marin County, which is across the bay from San Francisco, and I put on a virtual reality headset, and I was playing a VR ping pong game. And back then, the VR headsets were much bulkier than they are now. There were literally wires coming from the ceiling, so you knew you were in a virtual reality. And the graphics were terrible on the ping pong game. But the physics engine of the game was so good, the responsiveness was so accurate that it actually felt like I was hitting a real ball with a real paddle. So much so that at the end of the game, I tried to put the paddle down on the table instinctively, and I tried to lean against the table. Of course, there was no table, so the paddle fell to the floor. I almost fell over. And then I began to really wonder, how long would it take us as a civilization, as a technological civilization, to create something like the Matrix? And so that's really what led me down that rabbit hole. But I think the fact that video games are becoming more and more realistic. If you've seen, sometimes I'll show a slide which will show racing games starting with 8-bit and then show 16-bit racing games from the era of Nintendo, which was in the late 80s, and then show a 32-bit or a 64-bit racing game. There was a Matrix film, a fourth Matrix film that came out a couple years ago, back in 21. And at the same time, Epic, which makes the Epic engine, which is one of the Unreal Engine, which is one of the top engines for video game development, they released a demo called The Matrix Awakens. And it wasn't a full game, but the city in that game looked like it could have been. It was a mix of Berlin, San Francisco, but it could have been a real city. It was really hard to distinguish. The characters still weren't quite there yet, but now with the advance of AI, particularly with LLMs and AI having passed, most people think that chatbots have kind of passed the Turing test. In fact, in the book, I introduced this idea of the metaverse Turing test, which is we can talk about later. But the idea that AI is getting good enough for us to have conversations and relationships with it. There are people out there who have AI boyfriends and girlfriends. And I had been interested in this for a while because of my interest in virtual reality and my background in video gaming. And then a couple of years ago, I was in Cambridge in the UK, and this is the first time I had heard of this in the wild, where, meaning a friend of mine, she said, oh, her friend just broke up with her boyfriend, and so she got a replica boyfriend for a little while until she got a real one. And so that was the first time I really just heard about it, not within the computer industry, not within the video game industry. And that's when I realized, though, this is actually much broader than had been. So this idea that we would not be able to distinguish, both in terms of the graphics, but also in terms of the AI characters, I think all of that is lending more credibility to this idea that we could be in a simulation.
Hey everybody, I'm usually the one that asks my guests to judge their books by their covers, but today I'm asking myself to judge my own book by its cover. My newest book, Focus Like a Nobel Prize Winner, is chock full of advice, life tips, and focus and productivity tips from 9 of the world's greatest minds, Nobel laureates ranging from economics to peace to physics, of course. It launches September 9th, which is also my birthday. I hope you'll check it out. And my publisher's gotten Amazon to run a special just for listeners of the Into the Impossible podcast. You can get the Kindle edition for only 99 cents. That's less than a new pocket protector. So go to Amazon and get the Kindle copy today, because this special only lasts for the first week after launch.
Let's talk about some of the physics implications of the existence of a simulation. Let's talk about hardware versus software. So software, you quote, Mark Andreessen in the book, is, eating the world. I feel like LLMs are eating software because now you can basically have an infinite army of coders making any software application you want instantaneously. So the price of software is going basically to zero. But hardware, the physical world of monoliths and metals and things like that, is much slower. And I'm an experimental physicist, and it's much harder to make, as you saw in the lab, the experimental 3D printed objects that we have to make to render those, than to make a theory which may never be testable, like the simulation hypothesis, or the multiverse for that matter, which another topic you've written about. So let's talk about the limitations. Where are the limitations coming from? It seems to me impossible to think that they'll come from software. And yet I don't believe that AGI is upon us. I don't think we're any closer to it. I think it's, as I said recently, it's 10 years away and it always will be. But tell us, what are the limitations as you see them?
Yeah, absolutely. So first of all, I used Mark Andreessen's quote about software is eating the world, and I say information is eating the other sciences. In that, if you talk to a PhD in physics or chemistry, most of their time is probably spent on the computer. And more we're seeing, even with biology, what we're really talking about are the DNA sequences, and the genomes, which were, first posited by John von Neumann. So you've got this idea that information science may in fact underlie all of the other sciences. And then even within physics, there's this idea of digital physics, right? Whereas, when I was a kid, we were talking about conservation of momentum, conservation of energy. And now physicists are talking about conservation of information, and does information get created or destroyed? So there's a whole set of issues around the sciences that I think lends credibility to this subject. That said, I think I agree with you that we're not at AGI yet. And I think part of the reason why is that if you think of science fiction, AI is often presented as a discrete entity, if you will, like Data in Star Trek: The Next Generation. Or HAL
Right.
in 2001. But the AI we have today is more like the computer in Star Trek: The Next Generation, where you're just asking it things and it's giving you information. And so there's this divide between a separate entity that's self-contained and kind of this synchronized AI that knows everything and is constantly updating itself. If you've ever watched the Dune movies or read the original Dune book, there's a whole set of prequels. And in the prequels, humanity is enslaved by AI, and it's something that is a very popular trope in science fiction. Personally, I don't think we have to worry about that. But the reason I bring it up is there's an interesting element where Omnius, which was the AI, was basically it would learn all the time and had many copies of itself. So it was a synchronized AI. I literally called it the synchronized empire when it was ruling the humans. But then one robot decided it wanted to be separate from Omnius. And so it was non-synchronized. I think the name was Erasmus or something. But because that robot would learn through its own experiences and stuff. And I think we're missing that a bit with today's AI. And so I think embodiment and exploring the virtual world may be one of the reasons to get there. So I do think there are some limitations around AI that may come up. That said, computer science is often about optimization. And so even when we talk about the number of particles in the universe, will we ever be able to simulate that many particles? There's a lot of optimization that can be done so that we may or may not need to. So I do think those are some areas. Now, our hardware today, sure. I mean, when I talk about the universe being a computer, we're not talking about a 386 or today's NVIDIA's GPU.
Atari 2600.
Atari 2600. Right. So back in the 80s, if you were to say, hey, can you create a whole world like World of Warcraft that has 3D pixels, or Fortnite? We'd say, no, you can't. This is way too many pixels to keep track of. And so what happened between then and now is that 3D modeling became popular and better techniques were developed. And so now we only have to keep track of certain pixels. And so that's a key part of why I think you can't always draw straight line comparisons and say, well, this won't work in the future. There was a great case study for Intel where they kept trying to make their processors smaller, or actually more like fit more transistors. And it was in like the 2000s. And they said, look, if we keep going at this rate, our microprocessors will get hotter than the sun. Okay, so which meant that Moore's law would end. But it didn't, and the part of the reason why is they changed the algorithms, right? So they became more efficient, and they began to use what were called mobile processors at the time, which used less energy, but they also had reduced instruction sets on those. So that's where I think, yes, there will be limitations in our ability to produce this, but they may also be overcome with new types of algorithms and new optimization.
Before we get to the questions that, I think my audience will be really interested in terms of the quantum mechanical overlay on top of all of this, including wave function collapse, double slit experiments, and retrocausality, things you all discuss in the book, I do want to pay at least a little bit of, well, not lip service, but I do want to at least mention the fact that you're one of the few that's unafraid really to confront the possibility of, what religious texts could give to science that perhaps scientists are overlooking. So let's talk a little bit about your background. I don't think you've mentioned it much on many of the podcasts I've seen you on, but what sort of is your background in terms of faith, and how does it influence what physicists, computer scientists may be getting wrong, and ways to get us out of a rut that we may seemingly be in, at least towards getting to AGI?
So my background is, my parents are from Pakistan. I was actually born there, and then I moved to the U.S. and grew up in Detroit, in Michigan. So I grew up in a Muslim household. I was never particularly religious, but then, as I went to college, I started to spend more time exploring some of the Eastern faiths around Buddhism and Hinduism, particularly the esoteric aspects, the yogic philosophy of the Eastern religions. And then later I began to explore more of the Sufi traditions, which is the mystical tradition in Islam. And so I think whenever you grow up in a culture where your religion is not the dominant religion, you start to look at things a little bit differently, and you start to say, okay, well, what's in common between these different religions? So of course, we knew the stories of the Bible growing up, partly because they are there in the Islamic traditions, but also just because the culture has, the 10 Commandments, like all of this stuff is out there. And so I started to look at what's in common and what may be different. And I'm not afraid to talk about this idea, because I think that if you think of religions, how do they start? They usually start because someone, say the founder of a religion, has what religious scholars like to call a theophany. Like somehow the divine breaks through into the physical world. Now that could be a burning bush that's talking to Moses. That could be angel that appears to Muhammad in a cave while he's fasting and near Mecca in the desert. Or it's through a series of techniques. You have mystic who is then trying to explore beyond the physical world. So the yogic techniques, Siddhartha on the Buddhist side. You also have shamanic techniques. And of course, now we're learning more about psychedelics as a way to potentially perceive more than what's physical. But if you think of Plato's cave and Plato's allegory of the cave, most people know the general story, which is that you have people that are chained to one side of a cave, and what they're seeing is just shadows opposite the mouth. They don't know there's a whole world out there, and they're just seeing the shadows. But not that many people outside of philosophy have read the whole allegory. And what happens is that there's a guy, a philosopher, who breaks out. He goes outside. The first thing that happens is he's blinded because there's too much light. They've never seen the sun. They grew up in a cave. Then he comes back later and he tries to tell people what he saw. And of course, they reject that idea because that's all they know. And so with these religious traditions, they had to describe things that they perceived that were non-physical and might even be ineffable, right? Which is a term that means cannot be put into words, to the general population 2,000 years ago. And so how did they do that? They used metaphors, and often they used technological metaphors. For example, the wheel of samsara in Buddhism. Okay, that doesn't mean there's a physical wheel. They're using that metaphor. And even many of the stories about angels and what the function of the angels is, my name, Rizwan, is actually the Islamic name for the equivalent of St. Peter, which would be the angel that sits at the gates of heaven. Now, again, that's a metaphor. That doesn't mean there's one guy who sits there and decides for everybody, whether they get in or not. That is more like a function. And the same is true of many of the minor gods, for example, in the Hindu pantheon, where they have a function. There's something called the recording angels, both in the Judeo-Christian and Islamic traditions, where you have angels who are writing down your deeds, your good deeds and your bad deeds. And you have one angel for this, one angel for that. And in Islam, they call it the scroll of deeds. And they say when you die, you have to read your book and you have to see what you did. Okay. Now, that doesn't mean there's a physical book or that there's, a feather pen.
Same in Judaism, exactly right. Mm-hmm.
Yeah, but my point is those are technological metaphors potentially for something that is ontologically real that was perceived by the mystics and then translated. Today, we would say, well, what that really means is that everything is being recorded, and you would have to rewatch a replay of your life. And it turns out near-death experiencers have reported this. They call it the life review, where they say you have to go through every single event in your life, but from the point of view of other people. So it turns out in VR, I've done this before, you can take like a World of Warcraft session or a League of Legends session. And there was a startup I was involved with where you'd put on the headset and you can go back and rewatch the entire video game from any XYZ coordinate. And you could literally see what it was like to shoot yourself. And that's very similar to what near-death experiencers describe with the life review, which not all of them have a life review, but the ones that do have it. And so I'm not afraid to explore that to say, well, what if what they saw was something real? I mean, if 1,000 people go to China and they tell you similar stories, even though the stories may be different, one might have gone to the mountains, one might have gone to, Shanghai near the ocean, one might have gone in the south, that there might be something there and they're trying to describe it. And so for me, it turns out that if you look at what the old traditions were saying, including Maya in the Buddhist and Hindu traditions, which means illusion, turns out there's a similar metaphor in the Quran, which is el gururi matal, which is an enjoyable delusion, which is also represented as a game that we are playing. And so I look at that and say, well, today's best metaphor for that would be a massively multiplayer online role-playing game, which we are inside. We have a physics engine. We think it's real, but in fact, there is something beyond that. And so that's why I'm not afraid to get into the religious side. And I get attacked both from
the scientific and
but also
religious
from people
world,
that are too fundamental on the religious side. Although many folks in the religious side actually are very open to this idea.
I mean, I find it hard to envision ways that we could develop scientifically falsifiable, hypotheses, even from near-death experiences. My friend Michael Shermer's done a lot of work on this and basically asked them for not just the kind of really headline grabbing, I saw a light and I saw my deeds in a book, but who was in the operating room, while you were there? None of them can ever answer that. None of them can ever answer factual questions about the actual, car that hit them, or, in the studies that he's done and in terms of replicable scientific double blind, where they couldn't have known unless they really had some way of omniscience, but they do seem to have this tradition. I don't want to argue about that, but, people have their own experiences, but we here, really trying to look at the scientific basis for these things, where the religious side of things can give a little bit of color, or maybe the spice, which makes things very much enjoyable. And I think they do share commonality, as we were talking before we hit record. And basically the notion of a purpose and why we exist at all, and if we do exist, and if the simulation is correct. And some people go on the spectrum. You give different possibilities, ranging from Nick Bostrom to maybe me, a little bit more of a skeptic. From 100% to 99.999, with the infinite number of nines, down to 0.1. The question, or 0.00. The question is, what scientifically can we glean about the simulator? The simulation itself. So here's why I want to pivot to the physics kind of engine side. You already brought that up, thankfully. And that's that, as you point out, simulators, video game designers are really smart guys and gals, right? So they're not going to waste time, simulating stuff that is never going to be seen or can't be accessed, right? That's one thing they won't do. Or something that you'd need to get to, 1 out of, level 256 on Pac-Man allegedly does not exist, right? Because it would be 257 levels and they only had 8 bits or something like that. So it only goes out that high. So they're smart. They conserve. Like a spider doesn't, it could catch every fly if its spider web was a complete solid disc, right? Like your metal, the Keating metal, right? If it looked like that, it would catch every single fly. But no. It's going to try to catch flies of a certain size, so the web spacing only has to be so much. So it conserves its biological energy. So what sorts of inclinations or indications might we get as to the purpose of the simulation, the attributes of the simulator from basic physics? So let's start there. One thing you mentioned, and you do a great job of, is describing, what we call pixels or voxels and the rendering engines that take place now, and how they don't render, as I said, every single, minute of every single life that could exist in whatever games you guys like to play. I don't actually play many games. I do flight simulators, but even in flight simulators, they don't render like Nebraska when you're trying to land the Concorde or fly the Concorde underneath the Eiffel Tower, which is very hard to do, but you can do it. So they're not going to render everything all the time because it costs a lot of money, costs a lot of time, costs a lot of energy. So what sorts of energetic physical limitations would there be in a simulation?
Yeah, it's a good point. And you brought up this idea of conservation and optimization, which is something that I talk a lot about in the book. And, I will say I'm not a physicist, so I tend to rely on physicists' interpretations of quantum mechanics and particularly of quantum indeterminacy and the observer effect. But to me, the collapse of the probability wave, if we take that interpretation for a moment, of course, people have their own interpretations that they prefer, the multiverse interpretation, which I also think makes more sense in a simulated world. But if we start with the collapse, to me, that sounded like very much how we build video games, and we only render the parts that can be observed by your avatar.
It's a compression algorithm. It's basically
a compression algorithm. And it seemed to me that what we're finding is that the universe gets rendered as needed. Now, you can argue whether that's as an observer or it's via a measurement or an interaction. But to me, the golden rule is sort of render only that which is needed. And in computer science, we have this idea of lazy evaluation. And, lazy evaluation is such that, suppose you have a little expression that says x equals, 2 to the power or whatever, 2 to the fourth power, 16. But you don't use computing resources to calculate the value of x until x is needed, because if x is not in the computer program, why bother? And, when I was at MIT, and I hadn't thought about this in a little while, I worked with a guy named Greg Papadopoulos, who later went on to become the CTO of Sun Microsystems. And he was doing research on something called finely grained parallelism with parallel computers. This is back in the 90s, right? So today, we have computers that have multiple CPUs, multiple GPUs, but back then, for the most part, every computer just had a single one. What his research was doing was it would break down an algorithm or even a set of code, and it would break it into parts and figure out which parts could be run in parallel and which parts were happening together. And so to me, even if you have multiple observers all requiring collapses of probability waves that need to be kept consistent, that's pretty much how we do video games. So on the server, we send out information and we get information back. And now we happen to be doing this in person, quote, but if we were doing this on Zoom, we wouldn't really be talking to each other, right? I would be talking to my computer and then you would be talking to your computer and it would play back. And so, where I was going with that was just this model of having to synchronize multiple individual players to basically ensure consistency reminded me a lot of this idea of how do you have a collapse of the wave? Can you have multiple collapses of the wave? And the Wigner's friend thought experiment.
Entangled, right. Mm-hmm.
Yeah, and entanglement as well. So those were ways in which I really started to think through the quantum aspects, but also with qubits and quantum computing, and the idea that a qubit can be in multiple positions. It can be in superposition. And to me, as a computer scientist, that's really interesting. In fact, recently we were chatting a little bit about this before. We did a screening of The Matrix at the Coolidge Corner Theater in Boston, and this woman came up and introduced herself to me, and she bought 3 copies of my book, and she said she was the wife of Ed Fredkin. Her name was Joyce Fredkin. And Ed Fredkin was one of the first computer scientists. He was at MIT. And he was an MIT professor without having a PhD, which is pretty impressive. But he was exploring cellular automata back in the 1950s. He invented the Fredkin gate, which is a reversible gate. But just as importantly, he went out to Caltech, where Feynman was, and Feynman taught him about physics, and he taught Feynman about computers. And then Feynman came out with this talk that led to this idea of building quantum computers. And so you start to see the intersection with digital physics between computation and the physical universe. And I thought that was really interesting as well.
In terms of quantum computing, I like to bring out this, kind of cudgel against my friends that do it, which is that quantum computers are some of the best known and even imaginable devices for simulating the properties of quantum computers. It's kind of like string theory. String theory is like the best possible instantiation of the mathematics needed to understand string theory. I mean, these are devices that they're sort of, answers without a question yet. Yes, they can do things in terms of cryptography, and that is well known, and that was even envisioned by Feynman. But his main kind of championing of quantum computers was to solve what are called Lagrangians, and basically the energy distribution, how energy flows throughout out a quantum system, which is basically an atom, atomic systems that get perturbed by external forces, magnetic field, photons, et cetera, like that, right? So they're very good at doing that. It's not clear they're good at doing anything else. I mean, again, sort of analogous to string theory. String theory is very good at this kind of multidimensional thing, but we have no inkling that we live in a 10-dimensional, 11-dimensional universe, right? So it solves a particular type of problem, but it may be completely irrelevant, and therefore it's very interesting math. Now, I'm not saying they're useless. As you know, I'm building one here, so I have to talk my own book, but I have to be honest too, as a scientist, and say, look, these things, are often tossed about as solutions to everything, just like AI and AGI. There's no inkling that they can do any of the things that they're being proposed to do, not just in your book, but in other kind of hyped up analogies. Again, this is really bad for my bottom line because I am going to hopefully commercialize with some friends. But tell me, Riz, what are the actual hardcore necessities or the necessity of a quantum computer as it applies to the simulation? Because if it's really dependent on quantum computers, then it would seem to be almost a letdown for me, because quantum computers, we know a lot about them, even though we haven't really built very advanced ones. So I'm sorry to make it so long-winded, but what is or are the different applications of quantum computing? Is it a necessary thing? Is it a sufficient thing for the simulation hypothesis? Where do they come in your mindset towards getting to the simulation point?
Yeah, well, it's a good point, but I would add one word to what you said, which is the word yet.
Yet.
In that quantum computing may not be that practical yet. And what we find with technology development, or useful, practical or useful, what we find with technology development is we can't always predict exactly what the use cases will end up being. So when Intel invented the first microprocessor, the 4004, they thought the only usage they could think of for it was for control systems in factories, and they thought maybe they would sell a few thousand and that's it. And of course, today microprocessors are basically the infrastructure of the information age, and we have millions, if not billions.
Right, but just to push back with respect, we had vacuum tube, we had human computers, we had slide rules, we had analog computers. So it wasn't like it was an ab initio new thing, where we didn't have computing and then all of a sudden we had computing. It wasn't like going from an abacus to a quantum computer. So yes, it's true that they went up and they've developed beyond Moore's law, in fact, in some ways, but not in a radically different format than even a transistor switch or a vacuum tube switch, right?
Right, but you're right. With quantum computing, it's such a different paradigm that I think we haven't fully grasped even the philosophical implications. And I know you've interviewed David Deutsch, right, who, he modified. So John Wheeler is sort of my favorite physicist of the 20th century because of all the thought experiments he did. But he coined this phrase, it from bit, towards the end of his life. And he said that anything that looks like a physical object is actually, the particle really is just an answer to a series of yes-no questions, which is a series of bits. And then Deutsch modified that statement to say it from qubit, right? So if you think of particles as bits, then the qubit is the next kind of logical way of being able to represent the idea that a particle can be in superposition. Now, if we didn't have superposition, then we wouldn't need quantum computers. we could just do a simulation off of classical computing and classical physics models, and you have a physics engine that runs on math. But, supposedly quantum computers can solve problems which grow exponentially. We've talked about cryptography. A few years ago, I wrote an article just for fun because I was exploring quantum computing. I said, this was back in 2017. I said, how I cornered the Bitcoin mining market using a quantum computer. And of course, back then, the quantum computers, the only ones that were out were like D-Wave. Maybe IBM had a prototype at that point in time. And it was more a way to just explore this idea that could we explore all the way Bitcoin mining works is, you have this thing called a nonce, which is a random number that gets added to some bits, and you're trying to basically find a number that will make the whole thing hash to a small number that's lower than a difficulty threshold, and it gets more and more difficult over time. And today we effectively have mining pools for Bitcoin that are basically, parallel thousands of computers doing parallel processing, trying to find the right answer. And so, Deutsch has stated that he thinks the reason cryptography could be solved when it would require, more computations than there are particles in the physical universe is because of the multiverse idea. He thinks maybe we're going out and exploring these different paths and then finding the right answer. And I think in the end, that may be where quantum computing becomes useful, is when you want to explore multiple paths simultaneously. And in the case of some of these problems as they grow exponentially. I mean, it would literally take a classical computer thousands of years. And I hear the objection sometimes that we can't be in a simulation because it would take too much time or too much computing power to simulate all of these particles. It's the same kind of thing. So I think right now it's more at a conceptual level that quantum computing could be a way in which we could simulate the superposition of particles. But that said, if we're inside the simulation, it's very hard to speculate what's outside the simulation. We can speculate, but it's very hard to say for sure. It would be like Mario trying to, talk about physical, quantum superposition outside of the game. It would just be difficult to do, but it is an interesting topic to speculate on. And that's why
I want to turn to that because I think it's a fascinating kind of a topic that you explore in the book. Before we get to, this concept of ways you could prove it wrong, let's at least do what you're not supposed to do, which is to judge a book by its covers.
Hey, book lovers, we're judging books by their covers. We know we're not supposed to do it, but into the impossible, there's nothing to it. Let's take a look and judge some books.
Tell us, please, the title, origin of the title, the subtitle, and this cover illustration here.
Well, so, as you mentioned, this is a second edition, but the title, The Simulation Hypothesis, is terminology that really comes from Nick Bostrom, who popularized this idea that we could be in a simulation in his 2003 paper, Are You Living in a Computer Simulation? That said, he meant it to apply to only one of three possibilities, of which the third possibility is you are most likely in a simulation. But I think that the terminology has grown beyond Bostrom's original idea, which was based on ancestor simulations. And you have folks like David Chalmers, who tried to coin the term the matrix hypothesis in the same year, 2003. And I think, Chalmers has been on your podcast. I've interviewed him. He spoke at my class on simulation theory. But so I think the simulation hypothesis has become the catch-all term for this idea that we are in a virtual reality. Now, it's a very long subtitle. Normally, publishers would not let you have such a long subtitle, but they let me because the first edition of the book had it. And it says, an MIT computer scientist shows why AI, quantum physics, and Eastern mystics all agree we are in a video game. And remember, when I first wrote the book, ChatGPT wasn't even around. It was 2019. So this is why I've done the new edition, which has about 100 pages of new content. But I was more predicting where I thought AI would go, and it's moved even faster in that direction. Now, it's interesting, the cover, they gave me some cover ideas that I didn't like originally. It was just a bunch of geometrical shapes. And so I had them go back, and then they actually used AI to help generate this particular cover, which I love because it shows a person in a world that looks physical, but is in fact a virtual world. You can see the polygons, and that's how we build video games. Although now with AI, you can see the polygons on the guy there, for example.
Hard to see it. I never noticed it until you told me.
Yeah, and that's how,
very cool.
In a video game, if you've seen it without if you see how it's being constructed, there are these meshes that are based on polygons, triangles, number of triangles, and then you put the texture or the skin on top of it. So this represents that idea.
That's great. Oh, let's keep that next to the monolith. There we go. Put back where it belongs, next to the monolith. Okay, so I mentioned that I'd love to talk about some more of the physical limitations. So one of the physical limitations that you talk about in the book is that space and time may be pixelated or voxelated. So a volume analog of a pixel, a two-dimensional object, is a three-dimensional object called a voxel or a volume element. And you make the case that the Planck length is sort of reminiscent or perhaps representative of such a thing. And it's not exactly clear to me that that's the case. So I'll just walk through my argument, and then you can kind of, contradict that or, prove me wrong if you like. But the point that the smallest amount of space is related to this fundamental constants of nature, just three of them: the gravitational constant, Planck's constant, h bar or h, and the speed of light, which is definitely a fundamental constant as we understand it. Although we'll ask the question later on. I want to ask you, why is the speed of light so slow? At least if the simulation is as big as we think it is. But let's get back to this Planck's constant and the accoutrements that turn it into a length. So a different square, you go through square root of hc over g, something that has dimensions of length, and you make the case that must be the smallest element of length. But I want to push back again with love and respect and gratitude for what you do. But there's something called the Planck mass. So the Planck length is 10 to the minus 35 meters. So incomprehensibly small. It's less than the time it would take light to travel the distance of an electron or something, or that speed basically. And so it's incomprehensibly small. And that led many people, including Elon Musk, who was on the podcast for about 20 minutes last year, to speculate that this is, that is the fundamental limit of everything in terms of the, plenty of room at the bottom ends there. You can't go smaller than that. But there's something called a Planck mass, which you can also get from the same combinations to the 5th power instead of the 3/2 power, whatever. It works out to be correct. And that mass is like a 100,000th of a gram or something like that. It's a huge mass. I mean, it's a grain of sand, basically, is the Planck mass. So what if you said, you're someone who's fixated on, weight loss or something like that? You could never lose more than a quanta of the Planck mass, because that is of mass. That's the only mass you get from the combinations of length, energy, frequency, time, and gravitational constant. That would be preposterous. Obviously, you can, we weigh way more than that, and we can measure things in my lab that's 1,000 times smaller than that with ease. So I want to ask you, why is there so much emphasis on things like the Planck length, and when it's so refutable that there's nothing fundamental about it? It is a consequence of just arrangement of numbers, but there's nothing, absolutely nothing in physics says you can't speculate on things smaller than it, thousands of times smaller than it, perhaps, or infinitely smaller if it is truly zero-dimensional existing points.
Yeah, and I will say, I rely on the physicist's interpretation of this, but my understanding is that we can easily speculate half a Planck length, right? You can put that in, Planck length divided by 2 or divided by 10.
Right, yeah.
It's just a numerical calculation, but that we can't measure anything smaller than that amount. And so for me, if you think of, again, I'm coming at it from a computer science point of view. If you think of a rendering of a screen, you have pixels, and inside you can basically you can calculate this thing is moving from left to right, and it's moving sort of half a pixel, but you can't render it at that point. So you wait until it gets to the next pixel level, and then you render it. And so for me, it's acting like a pixel. And so the question that I'm asking is space quantized? Quantum mechanics leads us to believe that energy is quantized and that particles exist in quantum states, so they're discrete states. So is space quantized? And is time quantized? And I think the second one is an interesting question that we don't have an answer for yet. I mean, in fact, I was on stage with Avi Loeb, a mutual friend of ours back in Boston, and he says, well, I have a paper proving that, time isn't quantized. And that's an interesting point. But I think there are other physicists who are telling me time may be quantized. And so we don't know if there's a smallest unit of time. I mean, you can calculate the Planck time as being the amount of time it takes for the speed of light to get that small distance. But can we measure less than that? And if we can't, that might be another clue that we are basically in a frame type, like in a video, you have frames, 30 frames per second, that there is some level of discretization. And I think that's where, the work of people like Stephen Wolfram, Fredkin, who I mentioned earlier, and others looking at the universe as a set of discrete computations is an interesting model. So I like to ask that question: is space quantized? Is time quantized? Mm-hmm. And
do you think deja vu is a consequence of the existence of the simulation?
It certainly could be. And so, one of my favorite science fiction authors is Philip K. Dick. And I interviewed his wife, Tessa, while I was writing this book. And she encouraged me to look at a speech he gave in Metz, France in 1977. And there's a famous line from that where he says, "We are living in a computer-programmed reality." And then it pans to the audience and you see people like, what are you talking about? Remember, this is like the Apple
52 years ago
had come out, right? I mean, nobody had a personal computer at that point. And he's talking about a computer-programmed reality. So his wife encouraged me to go back and watch the whole speech. And if you watch the whole speech, what he says is that the only clue we have is when some variable is changed, some alteration occurs in our reality. And he said it would be as if we were reliving the same events. We were saying the same things. We would have a sense of deja vu. So he called deja vu a basic clue. Like in the Matrix, there's a famous scene where the cat is walking across the door, Neo looks at it, and then suddenly he looks and it's the exact same cat. And he experienced deja vu. But it is possible in a multiverse interpretation. One of the things that stuck with me after I started writing about simulation theory was if you can run one simulation, you can certainly run more than one. And it's very possible that we are in one branch of that simulated run, and that this has already been done, but now variables have been changed. And that is one possible explanation for deja vu. I mean, I've heard Michio Kaku and others speculate that it could be from a parallel universe, but in a simulated environment, what a parallel universe means is just another run of the simulation with slightly different parameters.
Do you think deja vu might be a consequence of us living in the simulation? I got you. Just joking.
Perfect
just joking.
demonstration.
That'll be good. People listening on listening
Could it be
online.
a
That's right.
glitch?
Let's keep going. The rest of the podcast is nothing but Brian asking Riz the same exact question.
Question is, would I change my answer
Exactly.
a little bit
Yeah.
each time?
Maybe the future retrocausal Riz is now interacting with us. Let's talk about the ethics of the simulation. I've often talked about, well, let's say we can simulate with perfect fidelity our ancestors. Let's say we could do that. I've often wondered if that is true, then why are there so many Kardashians? But that's not for today. We're not going to talk about that today. But the point is, let's say we could make a perfectly, perfect Farmville that, everyone's in there and they're basically thinking that this is great and that they're actually existing and they have a sense that we exist, and maybe it's, kind of tangential. Maybe they don't have concrete evidence, but we're talking to them, we're communicating with them. And then we suddenly, here at the University of California, we're having a lot of budget cuts and the Trump administration has cut a lot of the scientific grants that we have. So I have to turn off my quantum computer. Like when I was a kid, I could afford the Commodore 64, but I couldn't afford the tape drive. I was so poor, I saved up all my money from working at the Venice Deli in Dobbs Ferry to buy a Commodore 64, and then I would just have to leave it on. So I'd program it. I wrote a copy of Eliza, which you talk about in the book. I wrote it, took me 2 days to write it. And then my brother came in and he was mad at me. Kevin was mad at me and he switched it off, so it erased everything. So what are the ethics of this, type of existence? We are responsible for these children simulations or, kind of in a non-matrix reality. We're just playing around with it. Do we have ethical and moral responsibilities? Obviously, I'm going to ask you if the simulator of the simulated hypothesis, if he, she, it, they, them, or G, if they have a responsibility. But first, do we have a responsibility to say we make these high fidelity creations that seem to exist? Can we turn them off or cause them pain?
Well, I think, that's one of the ethical questions that comes up around the simulation hypothesis. And sometimes people say, well, because there's suffering in the world, therefore we can't be in a simulation because it would be unethical for the simulators, right, to do that to us. But I mean, when we run simulations, why do we run simulations? We run to see what might happen under certain circumstances. If it's like a pandemic, for example, that we're simulating multiple times, or if it's, the comet is going to impact the Earth. But in these simulations, there's no reason. In our video games, we actually do have characters, NPCs. And I like to make the distinction between the NPC version and the RPG version of simulation theory.
So please explain for the audience who might not be familiar, what's an NPC and what's an RPG?
So NPC stands for non-playable or non-player characters. And those are the AI characters within the video game. So the term comes to us from Dungeons and Dragons, tabletop role-playing games. But, if there's a bartender at an inn or a guy selling you weapons, they're NPCs typically because they're not controlled by you, the player and the character. And the RPG version stands for role-playing game version. And in that case, the player exists outside of the game and they have a character, what's called an avatar, which incidentally is a term that comes from Sanskrit. It originally meant when a divine figure comes down and squeezes themselves into a little body. And when the guys at Lucasfilm were making one of the first online role-playing games, multiplayer, not massively multiplayer, it was on a Commodore 64, it was called Habitat. They were looking for a term to describe this little 2D character on the screen, and they said it felt like they were pushing themselves down the phone lines into the small little character. And so they ended up borrowing this term from Sanskrit. And so the RPG version is closer to the Matrix version. In the Matrix, Neo, Morpheus, Trinity, they all existed outside of the simulation, but they had characters or avatars inside the simulation. And so I think you end up with different answers depending upon where you fall. Now, Bostrom's logic tends to lean towards the NPC version because everybody is basically AI and you have lots and lots of those. In the RPG version, which is closer to like a virtual reality, we are the players and we are the characters. And that brings out, I think, a different kind of morality. But if you've ever seen the movie Free Guy that came out a couple of years ago, it was about an NPC inside the game who finds out he's an NPC. And the game is a little bit like Grand Theft Auto. So the players' characters are like abusing these NPCs, but then he realizes he's an NPC. And so I think it's an interesting question, but it doesn't negate just because they're suffering inside a world that we as the creators of the world or we as the people inside the simulation, couldn't be in a simulation for that. In fact, that might be one of the reasons to have it a simulation is to be able to simulate suffering to figure out, how we can reduce suffering in our world.
Yeah, that's a fascinating kind of consequence of that, how you might be revealed, or how we might reveal it. I guess one question I want to turn back to our discussion of quantum mechanics. I've had recently Adam Becker, who wrote a wonderful book called What is Real. He also has a techno-dystopian version of kind of the abundant future that Andreessen and others have promulgated, and Musk, etc. It was the main subject of our interview, but when we talk about reality, locality, Bell's inequalities, and so forth, the questions of quantum mechanical interpretations come in. And you already mentioned one of them is the many worlds interpretation, popularized by Hugh Everett, a student of John Wheeler. Also coined the term black hole. The guy's just a phenomenal intellect. Was Feynman's advisor at Princeton. The question of, kind of computational compression and irreducibility comes up when you think about this. And in your video game experience, you only, as I said before, you only render what you need. You don't have to render Nebraska when you're flying the Concorde, as I said, underneath the Eiffel Tower in Flight Simulator, But to do that, there is an agent. And I don't think this is really covered quite so often. When you think about the simulation hypothesis as being economical, parsimonious, however you like, optimistic, you don't actually have to render everything, but you do have to know what you do have to render, to kind of avoid the Truman Show, like lights falling out of the sky or whatever, which, kind of it would reveal the game, so to speak. Although it's not clear that, couldn't happen or wouldn't happen. But let's think about the practical implications of it. So when you do the spawning of, say, a new character in Minecraft or something like that, or you're rendering just around where that character is based on, some physics engine trajectory of where they were previously. Farmville, you make the point, they keep growing crops and stuff like that, but they're not growing crops, that are completely inaccessible in some, fifth dimension that you can't reach. It's something related to your crops. I don't play Farmville, but I assume it's so. That is a measurement that has to be done. And as you know, when you do a measurement, you oftentimes, in most interpretations of quantum mechanics, unless you do subscribe to the many worlds interpretation, you are enforcing an outcome. You're not deciding the outcome, but you're deciding that the outcome happens. So for example, if we are being observed, there is a quantum process that is going to destroy the coherence that we previously had in our wave functions and even in our entanglement. So how does that get avoided? And I mean, how do you avoid that fact that for every compression, there is an observation to allow you to notify you that you're allowed to do compression? So you're actually kind of destroying the coherence and collapsing the wave function automatically. How do you avoid that in the simulation?
It's an interesting point. And I think, again, we can look at it from this axis I mentioned earlier, the NPC versus RPG axis. Because in the RPG version, there is an observer that exists outside of the simulation who is watching the screen or has on a virtual reality headset. Again, those are just metaphors. And maybe in the Matrix, it was a BCI or a brain-computer interface that was going in there. In the NPC version, the rendering depends on where you are in the simulation. And so, one of the topics that I discuss a little bit is this idea of the delayed choice double slit experiment, another experiment that Wheeler put out.
Why don't you explain it for the audience, just in case they might not be familiar with it?
So most people are familiar with Schrodinger's cat or the double slit experiment, where the particle of light has to go through either one slit or the other, but it's in a state of superposition, which is that it's gone through both until the observation or the measurement is made. Now, what Wheeler said was, well, what if the observation is made much later in the process? And he described it using the cosmic delay choice experiment. I think that's the simplest way to describe it because people can understand. So if we have light coming from a quasar that's 1 billion light years away, it's going to take 1 billion years to get here. And if there's a very strong gravitational object like a black hole in the middle, then the light has to go to the left or to the right. And we can set up telescopes here to catch the polarization of the light. So basically we can tell if it went left or right, kind of like some of the lenses that you're building in your lab here for the polarization of light. Now, if that black hole is halfway between us and the quasar, then that decision would have had to have been made 500 million years ago, right? So we're back in the age of the dinosaurs, or maybe even earlier. I don't know whether even dinosaurs 500 million years ago.
Early single cells, yeah.
Yeah, we may need a paleontologist to tell us. But what the delayed choice experiment is saying is that, well, it's not until the measurement is made here on Earth that the decision of whether to go left or right is made. So it's in a state of superposition. And so is it possible that the past itself is in a state of superposition until the collapse happens? And that would mean that that decision, it's a kind of retrocausality, if you will. And Schrodinger actually had a speech about this. I found this when I was looking around when I wrote my book, The Simulated Multiverse. He had an obscure speech from the 1940s where he said, not only are we, choosing the state of the particle, but we are choosing from one of multiple simultaneous histories. And so, he didn't write a lot about this, but if you think about that statement, it's kind of mind-boggling, right? I mean, it's weird enough if the world is built on information. It's weird enough that it's quantized. It's weird enough that the probability wave collapses. But if we are then choosing a past and filling it in, so with Farmville, for example, when you log in, you see what happened to your crops over the last 24 hours. Now, the computer is not necessarily sitting there and running, every single second to see what had happened until it's needed. So it goes back to the past and it says the probability of locusts or something happening, to your crops is such and such, and it calculates and it fills that in for you. So it's possible that there are these multiple collapses going on. And again, I'm relying on the physicist here, with these interpretations.
That's your first mistake, is relying on physicists. That's
and they don't always agree, right?
Exactly right. There's violent battles over interpretations of, which is interesting because we don't have battles about the interpretation of classical mechanics or electromagnetism, even though electromagnetism has features in it that are completely, literally unreal because they involve complex numbers and certain factors that we can't account for unless we make the concession that what we can observe is only a real number, which is something akin to enforcing the observation once you collapse the wave, not the wave function, but the wave. Let's talk about how we could detect where we are. I mean, this is something you must have thought about. You do discuss, actually. How could we discern the existence, first of all, and then the purpose, second of all? So let's start with existence. Could we look for glitches? Are there possibly glitches in the Matrix? My friend Tom Bilyeu, who you should meet in LA, he talks about, the Matrix was a documentary. It wasn't a real. So, but if that's true, we should be able to see, the woman in the red dress, her eyes are getting or she gets some wrinkles now after 25 years. So tell us, what sorts of cracks in the Matrix, what sorts of diagonal, I like to say that I know how the Matrix ends. We diagonalize it using UL decomposition. That's a super nerd linear algebra joke. I'm sorry. Sorry, Riz. You're getting all my dad jokes at once. But tell me, are there more plausible scenarios that you've encountered where we could get a glimpse into the existence of the Matrix through glitches and fragments of it?
People often ask, is there a way to prove we're in a simulation? And this ties to, another question I know that you have, which is it non-falsifiable? I mean, is it impossible to prove that we're not in a simulation? And if the simulation is perfect, then it might be very difficult to provide. But just because you can't prove something is not true doesn't mean you can't find evidence that it is true. For example, we could say there are no asteroids anywhere in the universe. Well, we can't really prove that, but we can certainly find asteroids, and if we find them...
You're getting one. Here's your fragment of an asteroid. This is a real-life meteorite.
Oh, that's great.
A fragment of an early asteroid, older than the Earth itself, maybe interstellar. We don't know.
Where did this fall?
This fell in Argentina, and you too can get one out there. Not only will you get one guaranteed if you are like Riz and you have a .edu email address, briankeating.com/edu, guaranteed to win one in the USA. But you'll get one by chance, perhaps, if you go to briankeating.com/YT. And those are ways to win it. And you'll get all the information about them, where it fell, how you can collect your own, where you can see, when you can see them, what you need to see them, and what kind of telescopes, binoculars, etc. you can use. So that's another gift for you to come here. But it is a fragment, an artifact, and what do they call the NFT from the early universe, at least the early solar system. So anyway, so asteroids, you're saying. Yes.
Absolutely. So I put it on the picture of Arthur C. Clarke here.
Go.
So that's appropriate.
Rama. Rendezvous. He's rendezvousing right now.
It's true. In fact, I was telling Avi Loeb that if you look at the estimated size of Oumuamua, it was almost exactly
that's right.
the estimated size of Rama from Rendezvous with Rama. But we were getting into ways we might look for evidence. And so I think, one of the ways we might look for evidence is this idea of looking for computational processes in nature. And, I think you've had Jim Gates on your podcast who talks about finding basically error correction codes in the equations of string theory. And, error correction codes are basically another way of compressing data in a sense. For people who don't know, if you have say a string of 8 ones in a row, you can add a couple of bits to that to say there are 8 of these. And that's how you can tell the integrity. But we also say that there isn't much information entropy in that string of bits because they're all ones. If you start
there's no
changing
surprise
them,
in them, right? Mm-hmm.
Yeah, there's no surprise in them. Then you get more information entropy, and they can have many different possible meanings as well. So we can look for evidence of computation in nature. We can also look for geometrical structures that might imply that the physical universe, has even pixels, depending on what type of, if you're inside a computer screen, again, really simple example, you can look at sort of the number of pixels this way versus that way, and how do things flow differently. So that's another way. Then there are physical glitches you can look for. And then there's a whole host of paranormal phenomena that could be considered glitches. And most scientists don't buy that. But again, I don't always agree, simply because if you're in a court and one side can always dismiss the other side as evidence, then of course you're always going to say, well, that evidence doesn't exist, because you can just say, I don't take that evidence. But people see, people see ghosts, which to me, if you really listen to people's observations, they say sometimes it looks like it's replaying the same scene over and over again.
Well, you have to be careful of confirmation bias too. If we're looking to have excuses to believe that the simulation or ghost or your dead loved one who you love so much can be resuscitated even digitally or artifactually, we have to be careful.
It could be, but my point was, okay, let's assume for a minute that people are actually seeing things, and then say, well, is there a way how could that be explained? And it's pretty easy in a simulation. You have memory that sits there. We have something called garbage collection in computer science, where we leave values in memory and we only clean them up, because it's too much work to clean everything up, only when we need to. And so you could have glitches from the past, which are just the code is just replaying the scene again and again until it's cleaned up. And so you could look for these types of weird glitches as well. And then, there are people who think maybe you can overwhelm the simulation, right? So there was a movie called The Mandela Effect.
What is the Mandela Effect?
So the Mandela Effect is this idea that a group of people remember history differently than it actually happened, at least as we know in this timeline. And it was named after Nelson Mandela, where many people remember him dying in prison in the 1980s. But of course, he didn't die in prison. He got out, president of South Africa, Nobel Prize winner. But it turns out there are lots of these little effects where a subgroup of people remember something happening that the majority don't remember. And so I use that as a starting point to explain this idea that if you run a simulation multiple times, it's possible that some people are remembering either because they've retained things in memory, or because they are players who've played it more than once but don't remember. And we go back to science fiction now. Philip K. Dick, in that speech, if you read the rest of that speech, he said you would need to find a group of people who remember an alternate past. And he wrote his book The Man in the High Castle,
about the alternate history of World War II,
about the alternate history, and he came to believe that was a real history that was rewound. And so I think that's an interesting way to think about the past. But then there are things like the Tiananmen Square,
Woodstock Mandela Effect. They say that the 3 times when people think they were at Woodstock, then actually
we're actually
were there.
Oh, that's interesting. I haven't heard that one.
Mm-hmm.
But with the Tiananmen Square, it was, did the tank run over?
Right.
The guy in front of the tank.
Which where the brain fills in gaps, right? Garbage collects, as you're saying. Right?
Yeah, it could be that the brain, but it could be if somebody has more proximity to that event. Like, for example, if they're ardent followers of the Reverend Billy Graham, and they remember his funeral, and they remember, people speaking at his funeral, they're more likely to have that memory be correct than someone like me. I couldn't tell you the difference between when Billy Graham died versus Martin Luther. Well, obviously he died later than Martin Luther King, but in general, I couldn't tell you from one reverend or another when they died. And so the question is, are there people who remember that? But again, whether you believe in it or not, it's an interesting way to think about this idea that simulations run again and again with different variables could result in these types of glitches.
And frequently we do it for a purpose, right? I'm a pilot. I fly little, planes around Southern California airspace, and we have to go into simulators, once every year or two to get up to speed. And it's much safer and more cost effective to do that than to go out and do it. So there's tangible benefits to running those simulations. To me, my insurance, might require it, et cetera, and so forth. We simulate weather. We look at, what's going to be the impact of a drought or a fire season on crops in California and whatever. But what is the purpose of the simulation, if it indeed exists, as you claim it does? Or you claim the preponderance of the evidence.
It's more likely than
more
not.
likely than not. But it could be 51%, as you've updated your let's skip that for now. But let's just go to to what would be some of the purposes of it. What would be the analog of my insurance company?
Well, so when people ask me that, I like to ask 2 questions. The first is, why do we run simulations? And the second is, why do we play video games? And the first is, what I think we were just alluding to with this idea that you can, when you run a simulation, you want to find out what is the most likely outcome. But you also want to figure out what is the most favorable outcome. And so you'll go back and you'll change variables and you'll keep running it until you get to that most favorable outcome. And then you try to steer things in that direction. Perhaps, the timeline where the Nazis and the Japanese won World War II did not lead to the best outcome. And so the simulators decided to rewind that. And we're just on another branch. And this branch may only last so long, whereas at some point in the future, people may collapse the probability wave and find a different simultaneous history than we have today. But so for simulations, there's a civilizational level answer to that question, which I think is this idea of the best outcomes, the most likely outcomes. Will we get to the point where we leave the planet? Could it be that we're trying to see if we're able to build other simulations? There's another simulation film from the year 1999 that came out 60 days after The Matrix called The 13th Floor.
Oh, right.
Now, it didn't get much attention because The Matrix was such a big cultural phenomenon. But in that, I'll give away the punchline.
Yeah, it's 25 years.
Yeah, it's been 25 years. So they're in 99 and they build an ancestor simulation, what Bostrom would come to call an ancestor simulation of 1937, Los Angeles. And then later they find out that they are actually, 1999 is actually a simulation from the year 2024.
Right.
So very recently. And what the people that come in from the outside, or from the future in that case, depending on how you look at base reality, say is that we made thousands of simulations and you're the only one that ran your own simulation, but you're using too much computing power. So we're going to shut you down. So there could be these great filter type purposes of that. It could also be that there are multiple civilizations being incubated in different planets. And the whole point of the simulation is to see when we meet and to try to simulate everything before that to see what might happen. Now, going to the RPG version, why do we play video games? Well, mostly to have some kind of fun, right? But we also try to have experiences that we can't have outside the simulation. And so this is where I'm not necessarily in agreement with Bostrom or others that if we're in a simulation, it has to be an ancestor simulation, or that the rules outside the simulation have to resemble the rules inside the simulation. So I can get into a game like a Lord of the Rings game, and I can maybe, get on a dragon and fire arrows and shoot orcs. And that's not something I can do outside. So there are experiences that I might want to have as a player that I can have in the character. Now, the nature of our world is pretty dark in many cases. There's a lot of suffering, getting back to the ethical questions, etc. But, I think that ties more to the idea of a soul basically coming into a body to have a human experience, which might include suffering, because perhaps there isn't as much suffering outside the simulation, and that's why we do it inside the simulation. So I think, there may be individual reasons where each of us have our own experiences. So if we're in the RPG side, we might have a storyline. So if you had asked me in high school what I was going to do with my life, or if you'd asked you, you'd probably have an answer that at least anticipated, in your case, becoming a physicist. In my case, I would have said I'm going to be a software entrepreneur, and then I'm going to become a writer. And I thought that would happen when I was the ripe old age of 28 is when I would make the transition, because I was in high school.
Go back to school, you got a PhD.
Yeah, now I went back to get a PhD later. So it's interesting. But I think we may have individual storylines. And of course, now we're in the metaphysical realm. So there could be a teleological purpose to the simulation. There, you may have fine tuning as a way of clipping the branches. It's possible that the multiverse idea holds with multiple simulations, but it's not infinite. So, one of the big objections is it's not a parsimonious interpretation, because you're literally creating a new universe, right? Not every second, but every so often. But if you're pruning the branches because they wouldn't lead you down where you want to go, then you have this direction to the simulation that it's possible we could be in something like that. I mean, at best, we can speculate just like video game characters can speculate.
So before I ask you the final, kind of hard question about, the simulation crashing, what's your next project? What's your next big event, simulation run for you in this branch of the multiverse? In
terms of simulation theory, I wanted to go deeper on two aspects that I explore in this book. And one of the aspects is the religious aspect. And so I want to go deeper on the religious scriptures and ask the question, what if at least the things that they have in common are real phenomenon, and there is more to the physical world than what we can see or even we can observe with our science, and really draw parallels as a way not just to connect science and religion, because I feel like these two have been growing further and further apart, but as a way to connect individuals of different faiths together, because there are many similarities. And for a newer generation, this metaphor of the video game is as good as the metaphors of the soul, putting on the body, like a pair of clothes, which is in the Bhagavad Gita. It's in the Sufi mystical traditions. It becomes a new way to think about if you've ever watched the show Battlestar Galactica, they have these AI characters called the Cylon who are, oddly enough, kind of religious fanatics, but they say, one of them asks, what is the most basic article of faith? And the answer is that this is not all there is. And so I want to explore that in a little more detail. And then on the other side, I want to explore this idea of digital physics and computation in more detail, including the history of some of the players in this revolutionary way of thinking about the physical world as information.
Last question. If it was all a game, if it's all a simulation, what's the winning strategy? How should we conduct ourselves?
Well, I think if you play a game, you may want to think about how you evaluate the game after you play. And so some people think there's nothing after death. Some people think that there is something after death. I take the near-death experience reports more seriously about life reviews because they end up seeing things that they could not have known. And so this idea that we may have to go back and review everything we did and how we treated other people from their point of view, I think should lead us to be more compassionate with others and to think about how we treat other people inside the game. Basically, a woman once said to me, I think my husband is an NPC. And I say, no, that's probably not a healthy way to approach this. I think, viewing everybody else as a player and that how you treat them is actually part of your challenge. Video games consist of quests and achievements. Part of the quest here is, do you abuse people or do you treat them well? And also, I think we're all drawn to certain professions, vocations, places. We all have different skills and strengths, just like in Dungeons and Dragons, we would roll the dice and you would have, so much charisma, so much strength, I didn't roll to be a basketball player, even though
rolled for the Riz. You got the Riz.
Exactly.
Literally.
So I think we lean into the things that we're drawn to, and that's how we play the game, is to do the things that we were meant to do, that our character was set up to do in this life.
Dr. Rizwan Virk, thank you so much for making the trek down here to San Diego. Hope we do it again for your next book and even for your previous book in the simulated multiverse. So much to talk about, so much cool technology and developments in the video game world and the AI world and the startup world. It's just an exciting time to be alive. I just love playing the game. I hope I can play it even beyond the biblical age of 120. Thank you, Riz. Thank you so much for coming down.
Thanks for having me here.
If you enjoyed this interview with Rizwan Virk, I know you're going to love my conversation with the master of the simulation hypothesis himself, Dr. Nick Bostrom. Click here for that video and don't forget to like, comment, and subscribe.